Hello everyone, this is Dr. E, and for today I'm going to share with you my tips on how I teach integration and area under the curve to my students, especially in working out problems involving integrals. Calculus can be extremely challenging for most students, but once they are able to visualize the reason why they're learning all those complex integral rules in solving area under the curve, it will be a lot easier for them to comprehend the processes involved in working with problems involving integration. So it's all about visuals and understanding the connection between geometry and calculus, and learning or working with integration is a perfect topic to integrate those two skills. And this is what I'm going to share with you. So for those students who are seeing this video, if you want to have more practice exercises on integral calculus from Riemann sums all the way to finding the volume of a figure rotated on an axis, it's in the description box down below. And for teachers, feel free to use all the videos at the bottom of the description box. And we're going to be talking about one of my favorite topics in calculus, which is integrations, because this is where we can show our students the applied mathematics when it comes to calculus. So first thing that I teach my students is to give them an idea on why we use integrals and integrations. And before giving them functions that are out of this world, I always start with functions that will give them geometric shapes, just like a triangle or a square, similar to the examples that I'm going to be sharing with you in a little while. So let them see the connection of some geometry formula in calculus, and then move on to curve or irregular shapes that we'll be able to still work with when it comes to calculus. So that's the first thing that I always share to my students, finding area under the curve given a certain function, usually a line or a linear equation, and then figure out a way on how to use their formula in geometry in a calculus problem similar to this one. And then once our function becomes a little bit more exciting, similar to f of x is equal to the square root of x plus 2, or a rational function, or a trig function, tell them that there is another way on how to estimate the area under the curve, and that is the Riemann sums. So Riemann sums, it's tedious, it's a lot of work, but this is how, or I would never skip Riemann sums to my students and just show them the formula for integrations or finding the area under the curve using our formula, because students need to be able to see the progression from geometry and how we use geometry to calculus problems similar to this one, just like what you are seeing in our screen right now. So we have 4 methods in Riemann sums: left-hand method, right-hand method, midpoint method, and the trapezoid method. And all of these methods, I use them, and I let my students play with this particular topic on finding the area under the curve, which is pretty tedious, but they are seeing the point. Just give them 1 or 2 problems at a time. And also the use of technology. So technology, using technology is not cheating. Sometimes well, not sometimes, but all the times every time I give them homework, I always tell them to use some web application that they could use to verify their answers. So making sure that the calculations that they're working on manually matches what the technology is showing them. So TI-84 or graphing calculator, it always helps, but there are a lot of web applications that students can use, and I welcome them to use technology whenever they need to, just to be able to help them understand what's really happening when they're calculating the area under the curve using Riemann sums. So this is how I teach my students this particular problem. So here you can see that I have two functions, an easy function and a not so easy function. This function is where we use geometry to solve for the area under the curve, where our function is just simply x, or a diagonal line similar to this one. So here students will be able to understand the notations and read mathematical notations similar to this one, finding the area of f of x between 0 and 2. So we have 0, we have 1, we have 2, and by doing so, calculus becomes more visual and it becomes more connected to geometry. So now they know that they're simply finding the area under the curve using a geometric figure, which is basically a triangle. So finding this area involves a formula for a triangle, which is half of base times height. And this is also a perfect opportunity for us to teach calculus notation, because this particular notation can be simplified in calculus. So instead of showing them this, you can share them the beauty of the integral notation of f of x dx, which is our function, integrated from 0 to 2, and we'll be able to find that this is similar to calculating 1/2 base times height using this function. And if you have, or if you want to see more examples of this, it's in the description box down below. And then we are going to move on to calculus, and this is why we're using calculus, because sometimes we have irregular shapes similar to what I'm showing right now. So we have f of x is equal to x squared. So this is a parabola opening upward. So now that we have our shape, a weird shaped parabola that is looking like this. So now that we have 0, 1, and 2, we are seeing that in geometry, we don't have a curved triangle anymore. It may look like a triangle, but it's not really a triangle. So this is where we can introduce Riemann sums to them, because Riemann sum is basically a process that we use to estimate our area under the curve using rectangles. It could be the right hand technique or the left hand technique. Basically, we have 4 methods on how to use this. So this is what I'm going to share with you with this particular example. And again, now that we have rectangle 1, 2, 3, and 4, using the formula from geometry and then adding them all up because of these slices, and we'll be able to introduce to them the beauty of Riemann sums and another way of introducing integral notation, so that our students will be able to understand the mathematical writing behind this particular problem. So this is how I work with integration, to share with them the beauty of mathematics, how you work out a problem using mathematical operations, and the beauty of writing mathematical notations, kind of like writing different language or alien language, but in something that we are all understanding because of mathematics. So this is how I teach my students integration. So geometric figures to ease them into the process of finding the area under the curve of irregular objects. So Riemann sum is another way of showing them the importance of integral calculus and the formula behind the integrations that we are using in calculus, and of course using technology, which is important nowadays because it's now 2021 and we know that technology is working for us, not for us to cheat, but for us to be able to understand mathematics better. And if you have any lesson idea on how you share or how you teach this particular lesson in calculus, comment it down below so that I'll be able to see or learn a few techniques from you guys. And for students who have mastered Riemann sums, do you have any applications that you can share with us? And hopefully students will be able to use them as well to be able to understand the beauty of calculating the area under the curve using Riemann sums and using calculus. And that's it for today. So that's the topic that I'm sharing with you. And again, this is just one of the many ways on how we can teach or understand integration. And hopefully you will see that integral calculus can be a little bit challenging, but if you can see the connection of integral calculus processes to something that we are more familiar with, like geometry, it will be a lot easier for us to manage the difficulty of learning calculus. So this is Dr. E, and see you again next time. Bye!